Welcome back to the show. Today, we are going to do something a little dangerous. We're going to step right off the edge of the map.
We certainly are. Usually we're dealing with things you can touch, history, technology, economics. Today we are dealing with the reason you can touch anything at all.
We're starting with the question,
Yeah.
the big one. The one that, if you actually stop and think about it for more than 10 seconds,
Yeah.
it really gives you a bit of vertigo.
Why is there something rather than nothing?
Yeah, that one. It's funny, I was sitting in traffic this morning just, staring at the bumper of the car in front of me. And I had this sudden flash of just weirdness. Like, why is this car even here? Why is there a road? Why is there a planet for the road to sit on? Why isn't it all just blank void?
That feeling is actually a recognized philosophical experience. The German philosopher Schelling called it Erstaunen, primal astonishment.
Oof, gone.
Yeah, it's this sudden realization that existence isn't the default setting. I mean,
Yes.
Nothingness should be the default, right? So the fact that anything is here is, statistically speaking, the ultimate anomaly.
And yet, we usually just drink our coffee and completely ignore it.
Well, we have to. I mean, if you walked around in a state of primal astonishment all day, you'd never get your laundry done.
Fair point.
But today, we are going to lean right into that vertigo. We are going to look at the sheer, staggering complexity of the world. From the neurons firing in your brain right this second to the physical laws that hold the entire galaxy together. And we're going to ask, how did all this happen?
Okay, so to help us navigate this, you've pulled together a really unusual stack of sources. Usually we stick to one-lane science or history. This is, well, it's a bit of a cage match.
It is. It really is. So we're looking at a transcript from a high-level panel discussion called The Darwinian Mirror. And it's just a fascinating collision of minds. You have Richard Dawkins, the evolutionary biologist, who is, arguably the world's most famous atheist. And then in the other corner, you have Richard Swinburne, a heavyweight Oxford philosopher and theologian.
So the unstoppable force and the immovable object.
Exactly. But it's not just them. We also have Sylvia Jonas, who is a philosopher of mathematics, which is a really interesting perspective, and Jessica Frazier, a scholar of Hindu philosophy. So it's not just the standard Western God versus science debate. There are some real curveballs in there.
And we're pairing that with a pretty dense essay by Jamie Thornberry called The Ontological Priority of Being.
Yeah, and Thornberry is going to be our anchor here. He provides the philosophical rigor. He's the one who sort of stands back and critiques the arguments of the scientists and the theologians, asking if they are actually answering the question, or maybe just dodging it.
So here is the mission. We aren't going to solve the riddle of existence in the next hour. I don't think we have the pay grade for that.
Definitely not, no.
But what we are going to do is unpack two radically different ways of looking at reality. Let's call them the bottom-up view and the top-down view.
Right. View A, the bottom-up view, says that all this complexity arises from simplicity. You start with dead matter, you add time and a mechanism, and eventually you get Shakespeare.
And view B.
View B, the top-down view, says that mechanism isn't enough, that you just can't get something from nothing, and that the universe itself implies some kind of foundational intelligence, or what you might call a ground of being.
Let's start with that bottom-up view. This is Dawkins' home turf, and in the panel he starts by talking about biology. And I have to say, even though I know the basics of biology, the numbers he threw out, they kind of broke my brain a little.
You mean the brain stats?
The brain stats.
No.
I knew the brain was complex. I didn't know how complex.
It's completely humbling, isn't it? I mean, Dawkins points out that the human brain contains about 86 billion neurons.
86 billion. I can't even visualize that number. What's a comparison for that?
To give you a sense of scale, that's roughly the number of stars in the Milky Way galaxy.
Inside my skull.
Inside your skull. But, the neurons are just the hardware. The real magic is in the connections, the synapses. There are something like 600 trillion connections between those neurons.
600 trillion.
And it's not a static web, it's electric. Dawkins asks us to imagine the nerve impulses. He uses this phrase that really stuck with me. He calls them rifle bullets.
Yeah, that was so visceral. It makes it sound almost violent.
Well, it's high-speed data transmission. He estimates there are about 4 quadrillion of these rifle bullets firing per second.
Wait. 4 quadrillion.
Per second.
So while I'm sitting here just struggling to even say the word quadrillion, my brain has already fired that many times just to process that thought.
Correct. And Dawkins' point here isn't just to dazzle us with big numbers. He's setting up the problem. He says that when we look at something that complex, a machine that processes 4 quadrillion operations a second, our intuition screams one thing.
It screams design.
Right, it has to. If you found a supercomputer in the middle of the desert, you wouldn't say, wow, the wind piled up this sand in a really lucky way.
No, you'd say, where's the engineer? Who built this?
Exactly, and he doubles down on this with these visual examples from nature. He talks about the stick caterpillar.
The stick insect is the classic example of this design problem, isn't it?
It really is.
I've seen photos of these things. It's not just a brown worm. It has these little ridges on its back that look exactly like leaf scars.
Yeah.
It has fake buds. It even has asymmetrical joints, so it looks like a broken twig.
And Dawkins brings up the leaf insect, too, which mimics a dying leaf. It even has fake rot spots on its wings to make it look like fungus has attacked it.
That's the part that gets me. The fake rot spots.
Yeah.
It's mimicking imperfection to achieve perfection.
It's incredible. And Dawkins is very honest about this. He fully admits that before 1859, before Darwin published On the Origin of Species, the design hypothesis was the only rational stance.
Of course.
If you saw a bird's wing with its aerodynamics and its lightweight bone structure, you had to assume there was a builder. It's Paley's watchmaker argument.
But then enter Darwin. And Dawkins says Darwin had the effrontery, which I think is just a wonderfully polite British way of saying the guts. I say, actually, this is all an illusion.
And this is the core of the Darwinian solution. It's the mechanism that explains how you get from, primeval simplicity to that staggering complexity without a mind, without a designer.
I want to dig into that mechanism, though, because I feel like when a lot of people hear evolution, they just think random chance. And that feels so wrong. You can't get a brain by just randomly shuffling a deck of cards.
You're absolutely right to be skeptical of pure chance. And Dawkins is very clear that it is not pure chance. It's a 2-step process. Step 1 is random variation. That's the dice roll. A baby animal is born with a slightly longer neck or maybe a slightly different colored wing.
Okay, so that part is luck.
But step 2 is non-random survival, and that's the filter. The environment brutally selects the winner.
But how does that create something as specific as fake rot spots on a leaf insect? That seems so targeted.
That's where the concept of arms races comes in. This is a key part of Dawkins' argument. Evolution isn't just an animal adapting to something like the weather. I mean, the weather is static. It doesn't care if you freeze to death. But an animal has to adapt to other animals.
The predator and the prey?
Exactly. Imagine a gazelle and a cheetah. If a gazelle is born with slightly stronger leg muscles, it survives. The slow gazelles, they get eaten. So now the average gazelle is faster.
Right, which puts pressure on the cheetahs.
It puts immense pressure on the cheetahs. The slow cheetahs starve. Only the fastest cheetahs survive and reproduce.
So the cheetah gets faster, which in turn forces the gazelle to get even faster.
It's an escalation. It's a feedback loop that drives complexity just through the roof. The stick insect didn't start out looking like a perfect twig. It probably started by just looking slightly brownish. The birds ate the greener ones. So over millions of generations, the bird's vision got better, which meant the insect's camouflage had to get better. The design we see is the result of millions and millions of years of warfare.
So that little fake rot spot is basically a battle scar from a war that lasted 10 million years.
That's a really poetic way to put it, yeah. So for Dawkins, the mystery of biology is solved. We have a mechanism, natural selection, that explains the illusion of design. We don't need a designer, we just need time and, well, death.
Which brings us to our first major pivot point. View A says, look, we explain the eye, we explain the wing, we're done. But then we turn to Jamie Thornberry's essay, and he basically says, not so fast.
And this is where we move from science to philosophy. And it can be a tricky transition, so it's worth slowing down. Thornberry argues that Dawkins is making what's called a category error.
Okay, define that for me.
A category error is when you treat things of one type as if they belong to a completely different type. It's like asking, what does the number 7 taste like?
It's a nonsense question.
It's a nonsense question. The categories don't match. Thornberry argues that explaining how something works, the mechanism, is not the same thing as explaining why it exists at all, the ontology.
He uses this theater analogy that I found really, really helpful.
Yes, the stage analogy. So imagine you go to see the musical Hamilton. You watch the actors moving around. You hear the songs. You understand the plot. You can explain everything that happens on that stage in terms of the script and the choreography.
Hamilton moves stage left because the script told him to.
Right. That's the mechanism. In our analogy, that's evolution. But Thornberry asks, does explaining the script explain the existence of the theater? Does it explain who built the stage? Does it explain who paid the electric bill to keep the lights on?
No. The play presupposes the stage. You can't have a play in a void.
You can't, exactly. And so Thornberry lists these prerequisites of evolution. These are the things that evolution needs in order to function, but that it cannot create itself.
Okay, so let's list them. What does evolution need to even get off the ground?
First, and this is a big one, it needs stable laws of chemistry. Because evolution is built on DNA. DNA is a molecule. It relies on carbon bonding with other elements in a very specific, very predictable way. If the laws of chemistry were chaotic, if carbon bonded today but refused to bond tomorrow, you could never build a stable molecule. Evolution would never even start.
So the chemistry has to be there first. It's part of the stage.
It's part of the stage. Second, you need the stable identity of matter. Things have to stay what they are. Third, mathematical regularity. And fourth, and this is the really big one, you need a system for information transmission.
We're back to DNA being a code.
We are. Evolution is an algorithm. It's a process of trial and error, save the results. But to save the results, you need a hard drive. You need a language. DNA is that language. And Thornberry's point is this. Evolution can write new sentences in the book of life, but it didn't invent the alphabet or the paper or the ink.
Gets a really strong image. If I find a book and I say, oh, I know how this book was written, someone just rearranged the letters, I haven't actually explained where the language itself came from.
And this leads directly to what Thornberry calls the information problem. See, Dawkins talks about starting from simplicity, like a single cell. But is a single cell actually simple?
Well, I mean, compared to a human, yes.
Structurally, maybe, but functionally, absolutely not. Thornberry points out that even the simplest self-replicating cell needs incredibly complex machinery. It needs error correction mechanisms. It needs energy processing. It needs a translation system to turn DNA code into actual proteins.
It's a factory. A tiny little factory.
It is a nanotech factory of unbelievable sophistication. And Thornberry argues that randomness can shuffle matter around like spilling a can of alphabet soup. You might accidentally spell the word CT, but can randomness generate semantic meaning? Can it create a system where the letters CAT actually refer to a furry animal?
So, syntax versus semantics.
Precisely. You can have the letters, but the meaning seems to imply a mind somewhere in the system. So Thornberry's conclusion is that biology might be solved in terms of how species change, but it relies on this foundational layer of order and information that it cannot explain.
And what's so interesting is that Dawkins actually seems to concede a version of this in the panel discussion.
He does.
Yeah. He admits that while biology is now the flatlands, where everything is more or less explained, physics has become the new cliff. He says the mystery has basically retreated from the design of a bird's wing to the origin of the laws of physics. So the problem hasn't vanished. It's just moved downstairs to the basement of reality.
And that brings us perfectly to our next segment, the frontier of physics.
Okay, this is where things get really, really trippy. We're leaving the world of caterpillars, and we're entering the world of the fine-tuning problem.
This is the argument that I think genuinely keeps physicists awake at night.
So what exactly is being fine-tuned? Are we talking about, like, the planets being in the right orbits?
No, much, much deeper than that. We are talking about the fundamental constants of the universe, the factory settings of reality itself. There are about a half dozen numbers that define how physics works everywhere.
Like what? Give me an example.
Okay, so like the strength of gravity, or the strong nuclear force, which is the force that binds atoms together, or something called the cosmological constant, which determines how fast the universe expands. These are just numbers baked into the fabric of reality.
And the tuning part?
The tuning is the fact that these numbers seem to be set to a razor's edge of precision. If they were even slightly different, the universe wouldn't be a place where life could possibly exist.
Give me an example. Let's say I have a dial for gravity. What happens if I mess with it?
Okay. If you turn the gravity dial up just a tiny, tiny fraction, everything clumps together way too fast, stars form and then burn out instantly. The entire universe creates black holes and just collapses back on itself in a big crunch. No life.
Okay, so I turn it down instead.
Turn it down and matter never clumps at all. No stars ever form. No galaxies, no planets. Just a cold, dark, thin soup of particles forever. Again, no life.
So we're standing on a knife edge.
It's more like a firing squad. Imagine you are standing against a wall. 50 of the world's best marksmen aim their rifles at you. They all fire. And somehow, they all miss. You are still alive.
Okay.
Now, you could say, well, if they hadn't missed, I wouldn't be here to wonder about it.
That's true. That's a valid point.
It is. But would you really just settle for that explanation? Or would you immediately assume, wait, they missed on purpose? Something is going on here. The precision is just too high to be a lucky accident.
So how does science explain the marksman missing? If we don't want to say God stopped the bullets, what's the other option?
The leading alternative, at least in theoretical physics, is the multiverse.
The multiverse.
Yeah.
I feel like I see this in every Marvel movie now. But what does it mean in this scientific context?
It's basically the infinite lottery solution. The idea is that our universe isn't the only one. There are infinite universes being generated all the time, maybe like bubbles in a cosmic bath.
And in each bubble, the dials, are set differently.
Exactly. So in bubble A, gravity is too strong crunch-ench. In bubble B, gravity is too weak freeze. Most universes are just dead duds. But because there are infinite bubbles, eventually, purely by probability, you are going to get a Goldilocks bubble where all the dials are just right.
And since we are here and alive, we must, by definition, be in the Goldilocks bubble. That's the anthropic principle again.
Yes. It solves the improbability by sheer brute force. If you buy enough lottery tickets, eventually you're going to win.
But Thornberry has a bone to pick with this, right? He doesn't seem to buy the multiverse as a final answer.
No, he really doesn't. He thinks it's a philosophical dodge. He argues that the multiverse doesn't actually answer the question of why is there something. It just kicks the can down an infinitely long road.
So?
Because you still have to explain the universe generator. If there is some kind of machine or law spitting out infinite universes, who or what built the machine? What laws govern that possibility space?
So you've explained the bubbles, but you haven't explained the soap or the water or the bathtub.
Right. Thornberry says that by invoking a multiverse, you are actually making the problem more complex, not less. Instead of explaining one fine-tuned universe, now you have to explain an infinite universe-generating mechanism. You haven't reached at the bottom. You've just made the hole infinitely wider.
Which brings us to the other major contender, solution number 2, theism. This is Richard Swinburne's camp.
And Swinburne takes a very logical, almost mathematical approach to this. He argues that God is actually a simpler hypothesis than the multiverse.
Okay, stop right there. I'd push back on that.
Please do.
How on earth can God be simple? If God knows everything and can build galaxies and is supposedly listening to my prayers and your prayers at the exact same time, that sounds infinitely complex. It sounds like the most complicated thing imaginable.
And that is exactly Dawkins' argument. This brings us to the heart of the debate, really. Segment 4, the battle for simplicity. This is where the whole thing lives or dies.
Dawkins just says, you can't explain a complex universe by inventing an even more complex wizard.
Right. For Dawkins, simple means made of small, unintelligent parts. A brick is simple. A wall is complex. A single cell is complex. A brain is super complex. He insists that you must explain complex things by building them up from simple things. It has to be bottom up.
So a God who has a mind is already way too complex to be a starting point.
Dawkins famously calls God the ultimate Boeing 747. He thinks positing God is like saying a tornado ripped through a junkyard and accidentally assembled a fully functional jet plane. It's statistically impossible.
So how does Swinburne defend this? Is he just ignoring the obvious complexity?
No, he's using a completely different definition of simple. He's talking about metaphysical simplicity, or what scientists call scientific parsimony.
Okay, I'm going to need you to translate that into English for me.
Okay. Think about numbers. Swinburne argues that theism postulates one single entity, just one, God. The multiverse, on the other hand, postulates infinite entities, trillions upon trillions of universes.
So logically, assuming one thing is cheaper than assuming a trillion things, that's Occam's razor.
Exactly. Don't multiply entities beyond necessity.
But what about the complexity of God's mind? That still feels like the sticking point.
This is where Swinburne uses what you could call the zero argument. He asks, what is the simplest possible limit to a being's power?
No, a medium amount.
See, medium is actually complex. If you have, say, 50 units of power, you have to explain, Why 50? Why not 49? Why not 51? Any specific finite number requires an explanation for why it's that number and not another.
Okay, I see that.
But infinite power, or to put it another way, zero limits, is simple. It requires no calibration. It's just unconstrained. Swinburne argues that a being with no limits is conceptually simpler than a being with some specific limit.
That's a brain bender. So the concept of infinity is simpler than the number 54.
In logic, yes. And Thornberry adds another layer to this. He distinguishes between what he calls structural complexity, having lots of parts, and unified intent.
Is this the personal explanation bit from his essay?
Yes. Think about an electron for a second. Why do all electrons in the entire universe have exactly the same charge and mass?
I just assumed they came from the same factory.
But there is no factory. They just are. Swinburne and Thornberry argue that it is deeply strange that the universe is so uniform. Why isn't it chaotic? Why doesn't gravity change on Tuesdays?
And they think God is the explanation for that consistency.
They use the analogy of a choir. If you walk into a hall and hear 50 people singing the exact same note at the exact same time, you don't think it's a massive coincidence. You assume there is a conductor.
A single intent, organizing the many different parts.
Right. Swinburne argues that the uniformity of nature, the fact that the laws of physics work everywhere all the time, is strong evidence of a single sustaining intent. A person is simple in this view because they provide a single reason for many different coordinated actions.
So, to sum it up, Dawkins sees God as a complex machine that needs a builder. Swinburne sees God as a fundamental unity that explains why there's a machine at all.
That is the essential standoff.
But we aren't just stuck in this Western binary of atheist scientist versus Christian theologian. Our source stack had some other voices that I felt really opened up the conversation.
Definitely. Which brings us to segment 5, Beyond the Binary. This is where we bring in Sylvia Jonas and Jessica Frazier.
Sylvia Jonas had this really interesting take on non-causal explanations.
She's trying to break us out of the habit of thinking everything is like billiards. You know, ball A has to hit ball B. She points to mathematics.
The 7 is not divisible by 3 example.
Right. If I ask you why is the number 7 not divisible by 3, you don't go looking for a physical cause. You don't say, well, an atom bumped into it in the wrong way.
No, it just is. It's a conceptual truth. It has to be that way.
And Jonas suggests that maybe the existence of the universe is like that. Maybe the universe exists not because some guy in the sky built it, and not because of a random accident, but because of a kind of conceptual necessity, like a mathematical truth.
So reality is a giant equation that has to exist in order to be consistent.
Something along those lines. It's a way to find meaning without falling into what she might call wishful thinking religion, but also without falling into the meaningless void of strict materialism.
And then we have Jessica Frazier, who brought in the Vedanta perspective. And I have to say, the text she quoted, it gave me chills.
The Nasadiya Sukta. It's from the Rig Veda, one of the oldest texts in the world. It's about 3,000 years old.
Can we read that part again? It was so striking.
Yeah, let me pull it up. It starts. Then was not non-existent, nor existent. There was no realm of air, no sky beyond it. Death was not then, nor was there aught immortal. No sign was there, the days and nights divider.
Then was not non-existent nor existent. That sounds like quantum mechanics.
It really does. It sounds like a description of the quantum foam before the Big Bang, a state of pure potential.
What I found so fascinating about this Eastern view is that it seemed to completely sidestep the God as a person debate. I mean, Swinburne is very focused on God as an agent with intentions. But Vedanta feels totally different.
It is. Frazier explains that in this tradition, the ultimate reality isn't an architect. It's not a builder standing outside the house he's making.
So what is it then?
It's more like a seed, a generative power.
A seed.
Think about an oak tree. The tree comes out of the acorn. The acorn isn't a carpenter nailing branches together. The acorn becomes the tree. The Vedanta view is that the universe is an unfolding of a divine potential that was always there.
That feels much more organic, less mechanical.
It's a top-down view, but it's a nature view rather than a king view. It argues that consciousness and matter are just different branches growing from the same single root.
So instead of asking why is there something, the answer is because the nature of reality is to express itself.
Exactly. Existence is an exhalation. It's what reality does.
I like that. But, and there's always we can get all poetic about exhalations and conductors, but then we have to look at the world we actually live in. And it is not always pretty.
The problem of evil.
Segment 6. Because if there is a designer or regenerative power, or whatever you want to call it, why is the world so full of suffering, so messed up?
This is the strongest card in the atheist deck, and
Right.
Dawkins plays it very, very aggressively.
He talks about the parasitoid wasp.
Yeah, the ectomon wasp. It's just gruesome. It lays its eggs inside a living caterpillar, the larva hatch, and then they eat the caterpillar from the inside out, very carefully keeping it alive as long as possible so the meat stays fresh.
That is pure nightmare fuel.
And Dawkins asks, what kind of good designer creates that? He argues that if you look at nature honestly, it doesn't look like the work of a benevolent father. It looks like the work of a blind, indifferent, and frankly, cruel machine.
The universe we observe has precisely the properties we should expect if there is, at bottom, no design, no purpose, no evil and no good, nothing but blind, pitiless indifference.
That's the famous quote. And it's hard to argue with when you're watching a nature documentary and you see a lion tearing apart a baby zebra.
So how does Swinburne handle this? Because he believes in a God of love. How do you possibly square that with the wasp?
He pivots from the animal world to the human experience. He uses a classic defense called the soul-making defense.
Soul-making.
He argues that the purpose of this universe isn't to be a hedonistic paradise, a place where everyone is just happy and comfortable and safe all the time.
I mean, that sounds pretty nice, though. I think I'd take the hedonistic paradise.
But Swinburne asks, what kind of people would that produce? If you never suffered, never faced a single challenge, never had to make a hard choice, would you have any depth? Would you have any real courage or compassion?
No, you'd be a spoiled brat.
Or a robot.
Exactly. Swinburne argues God wants to create saints, and to make a saint, you need a world that has friction. You need the possibility of pain so that you can choose compassion. You need the possibility of danger so you can choose to be brave.
So all the suffering in the world is like gym equipment for the soul. That's his argument. And he says this absolutely requires free will. For humans to be truly moral agents, we must have the ability to choose evil. If we were programmed to always be good, we wouldn't actually be good. We'd just be puppets.
Okay, I can see that for human evil. If I punch someone, that's my choice. But what about an earthquake? What about childhood cancer? That's not a result of free will.
That's what's called a natural evil. And Swinburne argues that a world with reliable, predictable physical laws that allow fire to burn and tectonic plates to move, is necessary for us to have any real agency. If the fire magically stopped burning every time I tried to use it for something bad, we wouldn't be living in a real world. We'd be living in a divine nursery.
So God has to step back and let the physics run, even if it hurts us, so that we can be independent agents.
Yes, he treats us as adults. And sometimes living in a world with sharp edges means you're going to get cut.
Thornberry has a metaphysical take on evil too, doesn't he? It's a bit more abstract.
He does. He defines evil as privation.
Privation.
It just means lack or absence. Thornberry argues that evil isn't a substance. It's not like there's an element on the periodic table called evilium.
Right, it's not a red gas floating around the room.
Exactly. Evil is like a hole in a shirt. The hole isn't made of anything. The hole is just where the shirt isn't. In the same way, he would argue that sickness is just the absence of health. Hate is the absence of love.
So how does that help answer the question?
It argues that the creator didn't create evil. He created good things like free will and physics and biology. But because these things are finite and not God, they can fail, they can break, they can have holes in them. And suffering is the experience of those holes.
I see. So it's not that God invented cancer. It's that biology, being a finite system, has the potential to break, and cancer is the name we give to one of those breakages.
Exactly. It's a very subtle philosophical distinction, but for people like Thornberry, it's huge. It means the ultimate source of reality is pure good, and evil is just the shadow where that good fails to be fully realized.
We're heading into the final stretch here, and I want to circle back to where we started, to the illusion. Dawkins calls design an illusion, but Thornberry has a final critique of that idea that I found really, really provocative.
This is segment 7. What you could call the trust problem.
Thornberry attacks the word illusion itself.
He says that to call something an illusion is actually a philosophically risky move, because the concept of an illusion implies you have a standard of reality to compare it to. If I say that oasis in the desert is a mirage, I'm implying that I know what real water looks like.
So if we say the design of the universe is an illusion, we are implicitly admitting we have a concept of what real design would look like.
Right. It implies we have this deep, unshakable instinct for teleology, for purpose, that we can't seem to get rid of even when we try to explain it away.
And this leads back to the brain thing again.
It leads straight back to the brain, to the trust problem. This is a classic argument. Sometimes it's called the evolutionary argument against naturalism.
Okay, break it down for me.
If Dawkins is right, and our brains are purely the product of blind, unguided evolution, what were they built for?
For survival. Finding berries, avoiding tigers, finding a mate.
Right. They were not built for finding abstract truth. They were built for utility. A belief doesn't have to be true to help you survive. It just has to be useful.
So if I have a belief like that rustling in the bushes is a hungry demon, I run away.
Yeah.
And I survive. It doesn't matter that it wasn't a demon, it was just the wind. The false belief actually saved my life.
Exactly. So if our brains are survival engines, not truth engines, why on earth should we trust them when they do something like advanced physics?
Why should we trust the monkey brain to understand the Big Bang?
Or, and this is the really recursive part, why should we trust the monkey brain when it constructs a philosophy like atheism? Or theism, for that matter? If the tool itself is fundamentally biased towards survival over truth, then every measurement it takes is suspect.
So Thornberry is saying that the simple fact that the universe is intelligible, the fact that we can use mathematics to predict the existence of black holes, the fact that we can even have this conversation, suggests something else is going on.
He suggests it implies that mind is not an accident at the end of the evolutionary chain, that there is some kind of fundamental correspondence between the human mind and the deep structure of the universe.
The idea that we were meant to understand it.
That the universe is, in some sense, built to be known.
That is a very heavy thought.
It flips the whole picture on its head. Instead of us being accidental mold on a random rock floating in a meaningless void, trying to figure it all out, maybe that figuring it out is the whole point.
So where does this whole deep dive leave us? We've covered a lot of ground.
We really have. We've looked at the rifle bullets of the brain. We've looked at the firing squad of the fine-tuned universe.
We've seen the bottom-up view, the idea that complexity climbs out of the mud through a bloody arms race of survival.
And we've seen the top-down view, that the mud, the arms race, and survival itself all presuppose a stage that was set by a mind.
And we've touched on that Eastern view, that maybe it's not a construction project at all, but more like a cosmic seed unfolding.
I think the key takeaway for me is that the word simple is the ultimate battleground.
How do you mean?
Is reality ultimately simple because it's just a pile of dumb, meaningless particles? Or is it ultimately simple because it flows from one single, unified, intelligent source?
I want to leave the listener with that image of the mirror. The title of the panel was The Darwinian Mirror.
Yes.
When we look out at nature, at the stick insect, at the stars, what are we actually seeing? Are we just seeing a mirror of our own brain's desire to find patterns? Are we just projecting design onto what is really chaos?
Or is it the other way around? Are we seeing a reflection of something that's really there? Is the illusion of design actually the deep truth? And is the mechanism of evolution just the way that truth gets built in time and space?
Is the mystery of existence a puzzle that we're supposed to solve? Or is it more like a language that we're meant to understand?
That's the question. And I don't think science alone can ever answer it. Science gives us the letters of the alphabet. But philosophy, and maybe for some, faith, is what tries to read the words.
Well, I'm going to be thinking about the 4 quadrillion bullets firing in my head all day now.
Yeah, try not to overheat.
Thanks for diving deep with us. This was a big one.
It was! Keep wondering.
See you next time.